Okay, so here we're going to be finding the molar mass of all the molecules that are in here. Just remember the molecules are basically these things, the things with the capital letters and the small numbers, right? And so you got three different molecules. You got S8, you got O2, and you got SO3. All right, so if you look at S8, it's only made out of sulfur, right? And so we just need to figure out what the molar mass of sulfur is. Sulfur is 32.07. And so this guy right here is 32.07. And how many sulfurs are inside this molecule? 8. Yeah, super easy. It's just 8. So this molecule is made out of only 8 sulfurs. So all you got to do is pull out your calculator, do 32.07 times, that's not good. 32.07 times 8, and that will give you 256.56. So S8 has a molar mass of 256.56. And remember, you have to write it as a fraction, so it's going to be grams over 1 mole. So 1 mole of S8. So this will be the molar mass of that compound. What's up? Where? This one? S8, yeah. Yeah, the molecule is S8. What was that?
S8. It looks like a 5.
Oh. Dude, see, he's criticizing my handwriting. Better? Trying to make it more SE for you guys. But I think it looks worse now. No, I understand. I'm told my handwriting looks like dog too. Okay, but anyway. Huh? Yeah, this is all being recorded. Okay, so the next molecule is O2. So if we take a look at oxygen on the periodic table, oxygen is 16. So since we have 2 oxygens in O2, we just need to multiply by 2. 16 times 2, that's going to be 32. And so the molar mass is 32 grams in 1 mole of O2. Okay. Any questions on molar mass? You guys chilling? Not too bad. Okay. Alrighty, and for the last one, SO3 is made out of 1 S. S is 32.07. Okay, and then we got some oxygens, but we got 3 of them, so we can just add 16 3 times. And then if we put them all together, we just need to do 32.07 plus 48 and 80.07. Okay, so that'll be the molar mass of SO3. Yeah, what's up? Yeah, good point. So these numbers in front of the molecules, those only matter for balancing. We don't use them for molar mass. So when we do the molar mass, we can just ignore those. Oh, Davini, can you give the ladies the notes over there? Thank you. Alrighty, so those are the molar masses. Any questions on that? You guys chilling? Molar mass easy now? Yeah. Easy peasy? All right. I hope so, because I don't want to see any of you guys next year. All right, so like I said, this will be important, so just make sure you guys have a molar mass down. You'll need a periodic table as well, so just make sure you guys have one available. Okay, so last time we met, we learned about how we can go from grams to moles, right? We did that fraction thing where we put 1 on the top, 1 on the bottom, we canceled it out. But today we're gonna be learning a different conversion, and so today we're gonna be learning how to go from moles to moles, okay? So moles to moles, I think it's a bit easier because you don't really need to do any math. And so when you have a chemical equation, it tells us the ratio between involved molecules. So I want you guys to write this word ratio right here. Okay, ratio. Okay, so just write the word ratio. Okay, ratio basically just means how many of one thing you need to make another. So if we take a look at this chemical equation, how many S8s are in the equation? Not 8, that's 8 sulfurs. Yeah, there's only one S8 molecule, right? And so this equation tells us that if I have one of these, I'm gonna need 12 oxygens. And so that's the ratio between them. It's a 1:12 ratio. Make sense? And that will allow me to make 8 SO3. So it's like a recipe. It tells us if I have one of this, I need 12 of these guys, and I can make 8 of these guys. Okay. So it's kind of like the relationship. All right, so we're just gonna do a problem with this just because it'll be easier to just do the problem. So let's say that we run this reaction down here, and we start with 2.5 moles of S8. How many moles of SO3 will be made? So just like last time, we want to start off by figuring out what our starting number is and what we want to end up with. Okay, that way we know how to set up our fraction. This is a second math class. Fun fact, science used to be called applied math because it's math in the real world. Okay, so what is the starting number in this problem? Yeah, so the only number in the equation is 2.5, right? So obviously it's going to be 2.5. But we need to be very specific about 2.5 what? We have 2.5 moles of S8. So we're going to write 2.5 moles of S8. Does that S look okay to you guys? Can you tell that it looks like an S, not a 5? Okay, just want to make sure. I can comment on your guys' handwritings too, but some of your tests are really hard to grade. I'm not looking at you. I'm looking around. Why are you getting defensive? Oh, for sure. Good for you. You gotta take the next one though. Okay. And then we want to figure out what we want to turn this into. So if we look at the question, it's saying how many moles of SO3 will be made. So we want to end the problem by figuring out how many moles of SO3 we're going to make. So basically what we're trying to do is we're trying to go from this and turn it into this. Okay. All right, so all we're gonna do is the fraction thing that we learned last time, so nothing crazy. So what we're gonna do is we're gonna start off by writing the starting number again, 2.5 moles of S8. And then we're going to set up a fraction. So if you guys remember last time, just like regular math, if you have something on the top of a fraction and you want to get rid of it, where should I put it on the fraction? Top or bottom? Yeah, you want to put it on the bottom. That way they're able to cancel out. Okay, because if you have one thing on the top, you have moles of S8 here, it can cancel out with moles of S8 on the bottom. And then whatever you want to find, you put on the top of the fraction. So you're going to put moles of SO3 on the top. All right, now if you guys remember, last time we said that if you have grams and moles on the same fractions, the numbers come from the molar mass. Okay, but this time we don't have grams and moles, we have moles and moles, right? So if you have moles and moles on a fraction, you're going to get the numbers from the chemical equation. The thing that we balanced, this thing right here.
It seems like it's made up.
Dude, I'm making this up as I go. It's fake. It's not real. All right, so let's take a look at this equation. What number is in front of SO3? SO3. 8. Yeah, there's an 8. So we put an 8 next to SO3 on the fraction. Yeah, and then 1 is what's in front of S8, right? And so on the bottom, we'll put 1. Okay. So when we have a setup like this, just remember all the numbers on the top we're going to multiply, and all the numbers on the bottom, we're going to divide. And so here we can just pull out our calculators, and it's a one-step problem. All we got to do is punch in our starting number, 2.5, multiply by 8. If you really want to, you can divide it by 1 if you wanted, but you're going to get the same number. So you can always skip the ones. And so your answer here will be 20 moles of SO3. And that'll be your final answer. And it's moles of SO3 because the moles of S8 cancel each other out. Okay. So it's basically the same thing we did last time. You're just getting your numbers from the fraction from the equation instead of the molar mass. Okay. All right, easy peasy. It's a little too early to be doing this, right? Because you're used to the end of the day. Now you're doing it in the morning. Okay, so we're just gonna do one big example together. And then I will have you guys get started on the assignment. But before we move on, any questions on this? Okay, so for the last problem for the lecture, you're going to be doing a problem that's very similar to what's on your assignment. And so we're going to be putting everything together, okay? So we're going to start off with an equation, but I'm not very nice, as you guys know. And so you guys are going to have to balance it on your own, okay? So I am going to give you guys about, I'll say 2 minutes. And then you guys can balance this equation. After you balance it, if you want to get started on this problem down here, you can. But as long as you can finish the balancing, that'll be good, okay? So I'll give you guys 2 minutes to balance this equation. You can work with the person next to you, and then we'll go over it in just a second. Balancing. Okay, so I'm going to block this for just a second so we can make that little table, okay? So if we take a look at the equation, the only two elements that we have are F, E, and O. Okay. That is not a straight line. There we go. That's not straight either, but okay. If you take a look at the left side, how many F's do we have on the left side? 1. How many O's? Okay. Let's go to the right side. How many F's? And how many O's? You guys are experts now. You are almost ready to join me in my enterprise of Breaking Bad. All right, anyway. So let's start with the FEs. Which side needs more FEs? The left, yeah. Left side is the side that has fewer. So we got to add to the side with less. So we're going to put an FE, and we can just add FE by itself because it's by itself right here. Okay, so this changes to 2. Okay. Now we got to balance out the O's, right? So which side needs more oxygens? The left. So we're going to add O, but we have to add O2 because, again, remember, this is like your mom's recipe. You cannot change it. You can only add more of what's already there, okay? So O2. So if we add O2, how many oxygens on the left side now? 4. Okay, so we have a problem now because oxygens are still not balanced. So we're going to have to add some oxygens to the right side. And same thing here, you can't just add an O by itself. You got to add what's already there, Fe2O3. And that's going to mess up all of our numbers now, right? So how many Fe's do we have on the right side? So we had 2, and then now we have 4 because we added another molecule, right? So that's going to be 4. And then how many oxygens on the right side? 6. Okay, 6. Okay, we are almost done. Okay, so if we take a look at the left side for Fe, how many Fe's are we going to need to balance out all of these? Yeah, we're going to need 2 more. So we're going to add 2 more, kind of running out of space. That gets us to 1, 2, 3, 4. And then we need to add another oxygen. So if we add O2, now we have 2, 4, 6. And so that is how you would want to balance that out. Okay, so a lot of extra steps now. But I think on your exam, it'll be about this difficulty. It won't get harder than this. Like, it's not going to be as hard as your extra credit problems. Those are impossible. Okay, so let's put the numbers in the front now. How many FEs do we have in total on the right here? 4. Yeah, 4. 1, 2, 3, 4. So we're going to put a 4 in front of FE. Okay. So here, we're gonna have to put a number in front of O2, but it's not how many oxygens we have, it's how many O2s we have. How many O2s do you guys see? 3. There's 1, 2, 3. Again, that's different from just oxygen. There are 6 oxygens, but each of the molecules are made out of 2, and so there's gonna be 3 total. And then lastly, how many of these molecules do you guys see on the right side? 2. So it'll be 2. So 4, 3, 2. So that's how you would balance it out. Do you guys have any questions on that? A little bit of a trickier one, but this is about the difficulty that you guys can expect on the exam.
I think you're making this up.
I am making this up. This is all fake.
I think I was that back.
For sure, yeah, completely different.
I heard he cooks.
Oh, you can't say that. He cooks food.
Oh no, yeah.
Yeah, food.
Not anything good.
What were you referring to? What do you mean something else?
Oh,
Forward this video to Mr. Pepik. Say a student's accusing him of cooking. Okay. Dude, false witnesses here.
I like you, Jesse.
No, you're not his Jesse. Okay. All right, so let's finish up the problem now. So it says if you run the reaction above with 0.75 moles of Fe, how many moles of O2 will you need? So let's start with the first. There's actually 2 questions, but let's start with the first one. Okay, so our starting number is going to be the only number that we have, which is 0.75 moles of Fe. Okay, so far so good? Okay, you want to end with what? What are you trying to turn the moles of Fe into? Yeah, you want to turn into moles. Yeah, moles of O2. Good catch. It says moles of O2. So we're going to be turning it into moles of O2. Okay? All right. So we're going to do the same thing that we've been doing. We're going to take the starting number, 0.75 moles of Fe, and we're going to set up a fraction. So I want to get rid of moles of Fe. So where should I put it on the fraction? The bottom, yeah. And I want to find moles of O2. So we're going to put that on the top. Moles of O2. Alrighty, so since we have moles and moles on the same fraction, where are we going to get the numbers from? Yeah, the chemical equation. All right, Chem EQ. So if we look at O2 on the equation, the number in front of it is 3. So we're going to put a 3 in the front. If we look at Fe, the number in front of it is 4. So we're going to put a 4 in the front. Okay. And all we need to do is put it into the calculator because now the moles of Fe can cancel each other out. And then now we just need to do the math. All we have left are moles of O2. Okay, so let's plug it into the calculator. We are almost done with this part. So our starting number is 0.75. What should we do with the 3 on the top of the fraction? Yeah, we're going to multiply by 3. And then the 4 on the bottom, we're going to divide. So our answer will be, we can round it to 0.56. Okay, so that's going to be the answer for the first part. How many moles of O2? It'll be 0.56 moles of O2. All right, so that's what we learned today. But like we said, we're always going to be adding stuff to what we learned. So we're going to have to go back to what we learned last time because the question ends by asking how many grams is that? So it's asking us how many grams is 0.56 moles of O2. So we're going to have to do another equation. And so this time we're going to be starting with this number. I know, so much work, right?
Would it not be like even less, like a tiny? If it's molecules,
Moles are not molecules.
or like, dude,
No, moles is a way that we count molecules. It's when we count. when we count like, I forgot the exact term, but it's like a billion, trillion of them at a time. Yeah, you go watch the molar mass lecture. Okay, so we start with this number and we're trying to turn it into grams, right? So this time we're going to change this to grams of O2. Okay. All right, so we're going to take our starting number, which is 0.56 moles of O2. We're going to set up a fraction. If I want to get rid of moles of O2, where should I put it on this fraction? The bottom. And since we're looking for grams, we're going to put grams of O2 on the top. Okay. All right. So if we take a look at this problem, you're going to notice that there's grams and moles on the same fraction, right? So if you guys remember, if I have grams and moles on the same fraction, where do we get the molar mass from? Or where do we get the numbers from? I just said it. You're going to get it from the molar mass. Make sure you guys jot that down if you guys didn't know. If you see grams and moles on the same fraction, you get the numbers from the molar mass, okay, where you add it up on the periodic table.
So moles is actually a lot.
Yeah, moles is where you can, it's a way that we count a lot of things at one time. A little bit confusing, but yeah, just a little bit. Okay, so molar mass. So if we take a look at O2, to find the molar mass of O2, we got to go on the periodic table. O2 is made out of 2 oxygens. And so if we go to the periodic table, oxygen is 16 each. So if it's O2, it'll be 16 plus 16. We actually did this earlier during the warm-up. Yeah, 32. So it'll be 32 grams in 1 mole. So this is the molar mass of oxygen right here. So all we need to do is plug this number in right here. So if you notice, 32 is next to grams, right? So we're going to put 32 next to grams. And it's per 1 mole, so we'll put a 1 right here. Dude, because a mole of meth is 242 grams. That's a fifth of a kilo. That's a lot of money. Because yes, because we're always finding the molar mass of meth. Because when I'm like, hey, let's find the molar mass of potassium nitrate, you guys are like, but I'm like, yeah, let's find the molar mass of heroin. You're like, oh, okay. No, I don't know. I don't make cocaine. No, I don't have access to coca leaves. The Colombian brothers control that. Anyway, okay, so we're gonna plug in our starting number 0.56. And then we are going to multiply that by 32. If you want, you can divide it by 1, but you'll get the same number, so you can ignore the ones. So the final answer is 17.92 grams of O2. And those are your 2 final answers. And that's what you'll be working on today. So yeah, good question. Usually when we're trying to measure air or like gases, we usually put them in containers and then we find the density, like we find how much there is of the gas in the container. Yeah, you can't put it on a scale because it'll just, a lot of gases float. Yeah, it's from the molar mass. Remember, molar mass is always 1 mole. So yeah, does that make sense? Yeah, no problem. All right, so I'm gonna give you guys the rest of the class period to work on the assignment. If you have any questions, let me know. If you want to check the answer key, let me know. But you guys have the rest of the class period to work.